Hello everyone, welcome to my YouTube channel TechSpot. This is me Harish Gopale. So basically in today's video we are going to discuss about DLAG and the RTL design implementation of DLAG. You can see the block diagram of DLAG. Okay, basically it is type of bistable multivibrator which is having two inputs D and enable and two outputs Q and Q bar. Here D means DLAG or transparent latch. Transparent latch means it will transmit as it is input to the output. Okay, and basically if I talk about its functionality, so when and only enable is high, then only the input D applies to the output Q. Means when enable is high, then only it will samples the data and we will get the output into the Q. You can see the block diagram of DLAG here. Okay, as I told you, it works when and only enable is high. If enable is 0, then we will get the previous data. Okay, if my previous Q is 0, then I will get the 0 only. If my previous Q is 1, then I will get the 1 only. But what if my enable is high, then it will work. So now we can see our other input, that is D. So now we have only two inputs for D, that is 0 and 1. So if I talk about 0, so you can see the output 0 only. If I talk about 1, you can see the output in black color. Okay, 0 means red color, 1 means black color. So what if my input value is 0? So due to this complement, this 0 become 1. So for this first AND gate, this input is 1 and enable is 1. So as per the truth table of AND gate, 1 and 1 output is 1. Okay, now the D is directly connected here. Sorry, here it should be 0. Okay, 0 and 1, the output is obviously 0. Okay, now we got the output of this first AND gate and second AND gate. Now when it comes into the NOR gate, so we know the truth table of NOR gate. It is the reverse of OR gate, and what it says, if any input is 1, then output can be 0. Okay, we can directly print it. So if you see here, okay, for this first NOR gate, my input is 1, so I can directly print it. My output Q can be a 0. Now this output Q is going feedback for this second NOR gate. So this 0 and 0, 0 and 0, as per the truth table of NOR gate, it is 1. So we got Q bar as 1. So we got the complement Q is equal to 0, so Q bar is equal to 1. Now when my D is 1, so due to this complement again it becomes 0. So and enable is 1. So 0 and 1, obviously as per the truth table of AND gate, output is 0. We got here 0. Okay, now from here D again, here by mistakenly I have to write here. Okay, so here my input is 1 and 1. So 1 and 1, output is here 1. Okay, now again as per the truth table now of NOR gate, if any one input is 1, then output is 0. So from this second NOR gate, we can get the output 0. Okay, now this Q bar is going feedback for this first NOR gate. So 0 and 0, we got as per the truth table of NOR gate, 0 and 0, 1. So here we got the 1. So these are the values here I have put. So okay, so if my enable is high, then only it works. So if my enable is high, whatever the input D, you can see 0 and 1, that is reflected into the output Q. Okay, 0 and 1. And when my enable is 0, we will get the previous value. Okay, now let's jump for the RTL design implementation of this DLAG on a Vivado. So you can see my screen. I have already written and simple behavioral code for the RTL design implementation of DLAG. Okay, so let's go through the code. You can see the time scale is 1 nanosecond divided by 1 picosecond, and I have kept module name, that is positive DLAG, because it works on a enable. When enable high, then it samples the data. So that's why I have taken input D, enable inputs, and two outputs as per the truth table, that is Q and Q bar. And as it is a sequential procedural block, so in Verilog we are having sequential procedural block, that is always at the rate. So inside the always at the rate, enable or D. And here I have simply used if condition. If there is enable, then D is assigned to the output Q, and negation of D assigned to the output Q bar. Okay, and when I execute this code, we got the schematic. So you can see the schematic. This is my D, input D and input enable. Okay, and these are the latch, one latch for Q and Q bar. At the end it is latch. Okay, now to verify this D latch, I have simply written a I have written simple test bench code also. Let's discuss that also. You can see the module name test bench for TB latch, and again the same input D enable Q and Q bar, and this is the instantiation positive D latch, but that is the name of my RTL code. Okay, and this is the instance one, that is the instance name, and I have instantiated all the signal by using dot operator. And here I have toggle in enable, I have toggle in 10 nanoseconds, and inside the initial begin I have given the value of D. Okay, now when I run this simulation, as I already run, so I am having waveform, so we can see the waveform. So you can see here, as I have explained you in while explaining the functionality, if my enable is low, then latch will hold the previous value of Q. So here if you see my enable is low, so that is the reason the previous value of Q is unknown, so we got the unknown value. Also my D is higher, but when enable is high, it sees the input D is high, so you can see output Q is high and Q bar is low. Okay, again at this point at 20 nanosecond my enable goes low, but as I told you, if enable is low, then latch will hold the previous value of Q, and if you see the previous value of Q, that is high, so you can see the output is higher only. Okay, similar for output Q bar also. Okay, again at this point at 30 nanosecond my D goes high, so and enable is high, so output Q you can see high. Again at 40 nanosecond my enable is goes low. Okay, and D is also goes low, but as I told you, when enable is low, it holds the previous value of Q, so previous value of Q was high. Okay, but again when my enable goes high, at this point you can see my input is high, so here you can see output is high, but at this point when my enable is high, you can see D goes low, so again you can see the output Q goes low, and here you can see the complement of Q, that is Q bar is high. Okay, so this is what the D latch, and so basically in this video we have discussed the functionality of D latch and the RTL design implementation of D latch. So if you are watching this video, then please click on this like button, and if you are new to this YouTube channel, then please subscribe to my YouTube channel. Thank you so much.